Hi, my name is Jenna Samuel, and I'm a postdoctoral researcher in the astronomy department at UT Austin. I'm really excited today to share with you my most recent work developing a new suite of cosmological simulations called BonFIRE and CampFIRE. This work was inspired by some recent observations from the James Webb Space Telescope, which have really revolutionized the way that we think about the formation of the earliest galaxies. When the James Webb Space Telescope first peered into the distant universe, here's one example of what it saw: a plethora of galaxies, some of which are extremely red, meaning they are some of the oldest galaxies that we have ever observed. They're also extremely massive in some cases, which is very difficult to explain under current galaxy formation theories. What's more is that JWST can also reveal the detailed internal structure of these galaxies, showing that some of them are extremely clumpy, and a subset of those are even just the size of single star clusters. All of this is incredibly difficult to explain in current galaxy formation theories, and in order to understand exactly how these objects were able to form within the first few 100 million years of the universe, we really need detailed simulations that can merge both the large-scale structure of the universe with the small-scale physics involved in star formation. And so I and my collaborators developed this new suite called BonFIRE and CampFIRE. BonFIRE is the large box that you see here, which models a huge volume in the early universe, so it gets you a large statistical sample of galaxies, whereas CampFIRE is a zoomed in region of the BonFIRE volume, highlighted by the red box here, that is resimulated with even higher resolution. And together, these two simulations can bridge this gap with observations of the early universe by simulating both star formation in the tiniest systems that are known to form in the very early universe, and also the largest systems that will eventually form huge clusters of galaxies later on. And so what we found when we looked in the simulation is that there are indeed massive galaxies, just like what JWST has been observing in the early universe. And what's even more interesting is that they're composed of up to hundreds of individual star clusters. We were also surprised to find ultra-compact galaxies, or galaxies that have sizes on the scales of individual star clusters. We can also make very quantitative predictions for the galaxies in the BonFIRE and CampFIRE simulations and compare those to existing models and observations of the early universe. So we can do things like diagnose the energy budget of galaxies with the UV luminosity function at the left here, and that tells us a lot of information about what's driving one of the last major phase transitions in the universe. Furthermore, we can make predictions for the formation of the very first stars, which are also called population 3 stars, which have an outsized effect on galaxy formation in the early universe. To sum up, I just want to say that I'm really excited to continue piecing together the puzzle of early galaxies using the BonFIRE and CampFIRE simulations, and I'm really excited to start extending this work into looking at the chemical enrichment from the first stars and its interplay with subsequent galaxy formation, as well as the use of AI techniques like simulation-based inference and surrogate modeling to hopefully expand the utility of the results coming out of this suite to more flexible and computationally efficient methodologies.